Hi guys, I wanted to give you some directions on 813, which we already did, but we're going to start out slow. So I'm going to have you do 837, which was in the body of the lesson, and write in your learning log. And if you don't have your learning log, I get it. You can just write it on your piece of paper or in your manual, your math notebook, I mean. And then I want you to just read the math notes on mean absolute deviation, and that's all you're going to do today. So I'm going to share the screen and show you what I'm talking about. Here we have 813. How can I describe the data? So this is talking about histograms mainly, and looking at statistics and data and trying to learn some vocabulary really. So the shape, if you look at number 35, 8-35, it tells you these 1, 2, 3, 4, 5 different terms for describing a histogram. So we have the word double peaked, like 2 mountains. You see A has 2 peaks and B has 2 peaks. Single peaked just means 1 mountain straight up in the middle. That would be this guy. It doesn't have to be in the middle though. It can be this guy also. This is single peaked. And this is this word skewed. So see how this one is symmetric? It's the same on both sides, kind of like a mirror image of each other. This one is not a mirror image. You can't draw a line down the middle and have the same on both sides. So this is skewed. It's leaning to the right. If it was over here, it'd be leaning skewed to the left. Symmetric means you can draw a line down the middle and it's the same on both sides. Same with this. This one's not symmetric and this one's definitely not symmetric. And then uniform would be straight across. So this one's the closest to uniform that we can see on this these set of 4 histograms. So that's what they're talking about when they talk about shape. What are they talking about when they talk about spread? So if we think of the class, for instance, we think that you're about 11, 12 years old, I think. So there's not a big spread. You guys are about the same age because that's how we teach in America. We teach according to your age group. And the average age between the same number of 11-year-olds and the same number of 12-year-olds in our class would be 11 and a half. You could divide them up and you right down the middle between 11 and 12. The average age is 11 and a half. If, however, you're 13, say, you're farther away from the mean of the class, the average age, you're up here, you're at 13 years old. So you're 11 and a half plus a half a year to get to 12 plus another year. You're a year and a half away from the middle. So your mean absolute deviation from the middle is a year and a half. Same thing if you're 10, if you're down here, you're also a year and a half from the middle. So you're a year and a half mean absolute deviation. We know that 10 is less than 11 and a half and 13 is larger than 11 and a half. And when we're talking about absolute values, it's all going to be positive. So we don't care that one of those numbers is less than the mean or one of them's larger than the mean. We just care how far away from the mean it is. So you found that out when you compared the 2 different basketball games. Was that this one? We found it on that one, but then we also did the basketball games. Oh, I guess that was in the previous chapter. Okay, so for number 37, which is what you're going to be assigned today, other than re-looking over 30 through 36, is you're going to look at this set of data at the right. It's organized in a frequency table. And if you remember histograms, looking at these on the y-axis, this is your frequency. So this would be some sort of assortment that you're comparing, and this would be how many fit into that category. So if I'm looking across the bottom here at the score 1, 2, 3, 4, 5, 6, 7, I would say my score 1, looking at this table, has 1 recorded score of 1, whereas the score 2 would go all the way up to 5. There'd be 5 frequencies in the box in the column for 2. 3, you go all the way up to 12. There's 12 instances where there was a score of 3. There's 15 instances where there's a score of 4. There's 11 instances of the score of 5. I hope you can't hear my dog snoring because he's right there and he's very snory. Let me give you a little picture of him. There he is. He's a little snore chowser. I hope he's not ruining this video. There's 11 scores of 5. 4 scores of 6, 2 scores of 7. So the first question says, if you were to create a dot plot of this data, how would you describe the shape using the words listed in the problem 35? So here's the words. And if you were to draw a frequency table with dot plots, it's like looking at it this way, right? So along the x-axis, you would have scores 1 through 7, and then the frequency would go up the y-axis, and you would have dots. You'd have 1 dot over 1. You'd have 5 dots over 2, 12 dots over 3, peaking at 4 dots, or 4, you'd have 15 dots, then back down a little for 5, back down for 6, and almost down to the bottom for 7. So you can see that that's going to make a pretty symmetric, single-peaked dot plot. How many total scores are there? Well, you might be tempted to say there are 7 total scores, but we want to see how frequently those scores were scored. So you would really have to add up all of these numbers to get how many total scores are there, because there's 1 of those, 5 of those, 12 of those. So add all those up. Then you're going to calculate the sum of those scores. And the way you're going to get the sum is you're going to say 1 times 1 is 1. Put a 1 here. 2 times 5 is 10. Put a 10. 3 times 12 is 36. 4 times 15 is 60. 5 times 11 is 55. 6 times 4 is 24. 7 times 2 is 14. So you have those products, and you're going to add those up to get the sum of the scores, all the scores. And then you're going to divide them by how many there were. You added up in B. And then you're going to calculate the mean. Well, that is calculating the mean. And then you're going to calculate the absolute deviation. So once you get what the average score was, which I'm pretty sure it's going to be this middle one because there's so many there, you're going to see how far away from the middle, from the mean, each of these scores are. So 1 is going to be 3 away from 4. 2 is 2 away from 4. 3, and so on. And then you're going to you're going to add them all up, like in this column, the difference. And the difference of the mean is going to end up with the negatives and positives. So in the end, you'll probably end up with something close to the number 1 for the mean absolute deviation. If that makes sense. Okay, you don't have to do the additional challenge when you get to the learning log. Under what circumstances is it appropriate to calculate the mean? Let me get some water. And the way you're going to figure that out is you're going to read the box. Right below here, which talks to you about why you would want to use the mean absolute deviation, which is actually a pretty important concept in math. So do your best on this. You should have, I believe, already done this homework. If you haven't, don't worry, I will be accepting late homework for the remainder of the year because I know we all have our own schedules we need to take care of, the stuff we need to take care of, and that's what I think is most important. So let me know if you have any questions. I will have office hours today from 11 to 12, as well as every Tuesday. So Tuesdays and Thursdays from 11 to 12, I'll have Zoom office hours, and I'll send you a link for that. Okay, bye, take care.